All right, so question 3, we're back to integration by parts, our first actual Calc 2 technique. And we can see that we have two different things being multiplied together, right? Two different types of functions. We have this 6x minus 1, nice little linear function, multiplying with a trig function, sine of 3x. And so we go, okay, we need to do integration by parts. There's no other way to get around this. The inside function, if you will, for our composition would be the 3x, and that doesn't really help us with that 6x at all. I was trying to think if there was a cute way for me to do this, but I mean, not really. I'm going to end up doing integration parts, whatever I do. I could split this into two separate integrals if I wanted to. There's no reason to. No one went down this path, but I could distribute the sine of 3x to both terms that we have in that first factor. So I could have a 6x sine of 3x and a sine of 3x. That's possible. It doesn't buy you a whole lot because you still have to do your integration by parts. So I'm not going to go down that path, but it is another possible way you could tackle this problem. So I'm going to go ahead and just integration by parts. We know typically it makes sense to set any sort of algebraic bit as RU in that integration by parts formula because it'll get simpler when we take the derivative. So in this case, du will be 6 dx. And also good practice to go ahead and make the dv in my integration by parts formula equal to any sort of trig function or exponential because they basically stay at the same level of complexity as we integrate them. So the antiderivative of sine, this is where most every student lost points, is right here. And for the most part, grab the correct u and dv. We just had a lot of trouble, even though they were written on the board, recognizing that the antiderivative of sine is negative cosine. And then we do have a baby chain rule happening here, right? There's a 3x. So technically, since we're integrating, we'd want to do a little bit of u sub here and divide through by that 3 in the end. So we had some mistakes there. A lot of folks not having the negative. A whole lot of students either multiplying by 3 or not doing anything at all with that, that argument of 3x. So there we are. That's what we should have set up. And after that, this question becomes pretty straightforward. I'll write down my integration by parts formula. The integral of u dv is equal to uv minus v du. And so we can just go ahead and grab all those pieces from that setup we've just done. We have our 6x minus 1. We've got to multiply all of that with my negative cosine of 3x divided by 3. For the most part, we did really good here. There wasn't too many lacking parentheses. But if you didn't have parentheses and there's only one of you on that 6x minus 1, that would not be correct because then the cosine, that little trig bit, is only multiplying to the 1. You could also go ahead and clean this up a little bit, bring that negative sign out in front of everything. You could distribute the negative sign. So however you wanted to do it. Some students actually distributed the whole cosine of 3x to everything. I don't know. There's no beauty's in the eye of the beholder here. Okay, and so I still need to subtract off the integral of v du. So v, okay, it was a negative, so it's going to be positive. Oh, and then I'm going to have the 6 times the 3, so this will become a 2. 6 times 3 is 2. So a lot of 1/18 and things like that, but throw these things into your calculator. We have 6 times a 1/3, and then we still have our cosine of 3x dx. All right. And here was another place that we had some issues. Students got excited. They were like, cool, I did stuff. I plugged into the formula. But the whole point of the formula is that now we have something we can actually take an antiderivative of, and we can go ahead and evaluate this. The antiderivative of cosine of 3x is sine of 3x. No need for a negative here. Just like in my dv to v move, I need to divide by 3 for that u sub that we're not going to bother writing out the steps for. We still have a 2, we still have a plus, and we need to get our plus c now. Didn't need the plus c in the previous step because that integral symbol, that indefinite integral, still had a plus c there. So that is the final answer. Lots of variations in terms of how to write this, but that was really the only place to go. Most of the mistakes were just pluses and minuses, or forgetting to deal with that 3x when you were taking antiderivatives. This problem tended to go pretty well for most students.